Fun stuff today. So we got our vocabulary under control. We know our vocabulary. So here we go. Hey, our notes here, 7.2. Number 1. You've got 3 matrices. And we're going to answer some questions about them. What are the dimensions of matrix A?
2 by 2.
2 by 2. 2 rows, 2 columns. Perfect. How about B?
2 by 3.
2 by 3. Yep, those are the dimensions. What do we mean by A sub 2, 1? What does that mean? A sub 2, 1. We're going to look at matrix A, and we're going to find the entry that is in the second row, first column. So the answer would be 3. And then B sub 1, 2. What's B sub 1, 2? First row, second column. So that would be 0. And C, C sub 3, 1. Can't do that because there's no row 3. Yeah, so that one there isn't one. Okay, now we're gonna add A and B. And I'm gonna tell you you can't do it. Can anybody figure out why you can't add A and B together?
They have to be the same dimension.
They have to be the same dimensions. So I can add A and C. A and C can be added. And when I add them, I'm going to get a new matrix. Any guess what that new matrix will be? I'm adding A and C. Any guess what's going to go here?
0.
0. Very good. Here we'll go 3, 7, and -4. So how do I add matrices? First of all, they gotta be the same size. And second of all, I just do it entry by entry. So that, and so on. Very, very easy. Would you agree?
Yeah.
Okay. 2A, I think we may have talked about that yesterday, I can't remember. Anybody have an idea of what I would do for 2A? Multiply everything by 2. It's like a big distributive problem. So everything in A gets times by 2. So 2, 4, 6, -8. Nothing to it. 2 is called a scalar. We're doing scalar multiplication here. We're just multiplying every number by 2. 2C minus A. 2C minus A. Any idea about that one? So let's take 2C. So 2C would be -2280. Is that all right? And now we're going to subtract A. Now, we're going to subtract the same way we added. It's a subtraction. So we're going to take -2 minus 1. -3. And then 2 minus 2. And 8 minus 3. And 0 minus -4. 0 minus -4. Can you do B minus 2A on your own, G? Can you do B? No, we're shaking our head no. Why can't we do B minus 2A? they're not the same size. And when we add or subtract, the matrices have to be the same size, same dimensions. So that is a no solution problem, right? Can't do it. All right, now we're going to multiply. And the rules for multiplication are different. All right, so we are gonna multiply A, matrix A, times F. Okay. Now this, the first time we do this, it's gonna seem a little confusing maybe, but you'll get used to it. Gotta fix my attendance. Okay. Here's the rule for multiplication. What are the dimensions of this matrix right here?
2 by 2.
2 by 2. What are the dimensions of this matrix? 2 by 2. For multiplication, these two numbers must match. They don't have to be the same size. These two happen to be, but they don't have to be the same size. You just have to make sure the columns of the first match the rows of the second. These two numbers have to match. And these two numbers tell you how big your answer is going to be. So these two match, that means that I can multiply. And my answer will be a 2 by 2. So again, kids, we can have a 5 by 8 and an 8 by 7, and they're multipliable. Can't add them, but you can multiply them, okay? These have to match in order to multiply. Okay, now how does it work? Well, we're gonna try to be organized. We're gonna fill in this blank first. We're gonna figure out what number goes in that blank. Now, would you agree that spot is row 1, column 1? So, we are gonna multiply the numbers in row 1 times the numbers in column 1. Remember, everything is rowed in column. So row 1, column 1. So I'm gonna write down the numbers in the row. There they are. I'm gonna write down the numbers in the column next to those numbers. So I write down 1, 2, and I write down -1, 3 next to them. Now I'm gonna multiply each pair and add them together. So -1 plus 6, this number is a 5. Okay? It's a lot, I know, but we'll get it. Now I'm gonna move over here. What is that? That position is still row 1, but now it's column 2. So I'm gonna take my row 1 numbers times my column 2 numbers. So 1, 2, 5, 0. So I multiply and add them together, so I got another 5. All right, now what? Row 2, column 1. Row 2, column 1. So I write down row 2, and next to those numbers, I write column 1, and I multiply and add. So what do I get there? negative 15? Isn't it negative 3 and negative 12? That would be negative 15. And finally, row 2, column 2. That's a lot. Right? All right, let's multiply the same two matrices in the other order. So negative 1, 5, 3, 0, times 1, 2. So now we are doing F times A. Two by two, they multiply, and the answer will be another 2 by 2. Remember, the outsides tell you how big your answer is. Okay, do you think you can put this thing together?
Yeah.
Row 1, column 1. That's this spot right here. Row 1, column 1. So negative 1, 5, and 1, 3. Did you get 14? So what's this? This is row 1, column 2. So row 1, column 2. Negative 22. Do you feel like you can do the bottom row by yourself? All right, let's do it. You're gonna use row 2. What'd you come up with right here? 3, perfect. And what'd you come up with right here?
6.
Yep, right on. Very, very, very good. All right, now one thing to notice here. This was A times F. That was F times A. Did I get the same answer? No. Matrix multiplication is not commutative. It matters. The order you multiply matters. So make sure you're multiplying in the right order. All right, next problem is D times E. Matrix D times matrix E. What do you think about that?
It doesn't have the same dimension.
What are the dimensions of D? So it's 2 by 2. What are the dimensions of E? Wait a minute, what's our rule for multiplying? These have to match. So guess what? Can't multiply. So letter C, problem C, is no answer. Can't do it. Cannot do it. Because these don't match.
We write that as the circle.
You can, yep. Now, can I do D times G? What are the dimensions of D 2 by 2? What are the dimensions of G?
2 by 3.
Okay, these are gonna multiply, right? And the answer is gonna be a 2 by 3. All right, so let's see if we can get this figured out. E times G. And we're gonna get a 2 by 3. So I gotta fill in 6 different blanks this time. Row 1 times column 1. So 1, 1 times 1, -3. Did you get -2? Perfect. We'll do one more together and then you can finish it up on your own. So 1, 1 times 2, 1. Because now I'm finding that number, which is row 1, column 2. Row 1, column 2. So I got 3 for that one. Did you? Am I rushing you, or do you feel like you really can fill in these blanks? Do you know how to do it? Fill in them? Okay, go ahead. Let's see what you come up with. It's easy to make mistakes, so I may have a mistake up here. So you guys can check me. This is what I got. Everybody else got that too? Perfect, perfect, perfect. One more. One more. I guess there's one back too. We're gonna multiply G times Z. Now, can we even do it before we get too far into this? Is this even a doable problem? Well, dimensions here are 2 by 3. Dimensions here are 3 by 3. So we can do it, right? And our answer will be another 2 by 3. Now, this is gonna have more numbers, so you're just gonna have to do more arithmetic. Because row 1, 1, 2, 3, column 1, 1, 1, -1. Now, does everybody see what's going on? Row 1, column 1. That's this spot right here. So the numbers in row 1, 1, 2, 3, and then the numbers in column 1, 1, 1, -1. So we're gonna have to do all that multiplying and adding up. Did you get 0? Okay, now we're gonna go row 1, again, we're sticking with row 1, but we're doing column 2. Did you get 6? And finally, row 1, I have 18 for that one. It's easy to make arithmetic mistakes, so you have to be careful. Alright, go ahead and do the bottom row. So now you're gonna do exactly the same thing, but you're gonna be using row 2. Row 2. So you're gonna be using -3, 1, and 0. Let's see what you can come up with. Anybody willing to volunteer your numbers that you got?
Is it, this could be completely wrong. -4, 5, and 3.
I don't know. Let's check it out and see. So, row 2, column 1. I think you made an arithmetic mistake. Because -3 and 1 would actually be -2. Alright, let's see if you did the next one. I think 5 is right. And for this one, 3. Yep, you got that right. Yep. One more multiply on the next page. Can we do it? Let's check. Can we multiply F times G? I think we can. Do I have a volunteer to come up and do it on the board for us? F times G. Who's gonna do this? Someone? Please? Thank you. And we're all gonna do it at our seats. And see if we can match trick. let's see what happens, Greg. When you did row one times column one, you missed this negative right here.
I'll catch you.
Otherwise, I think it's right. What did the rest of you think?
Oh,
That look good?
how do you get the last two numbers on the right? The third column.
So, let's say this guy right here,
Mhm.
he is in row one, so negative 1, 5, column 3. That number, row 1, column 3. So we multiply row 1 times column 3. Okay? And then this one would be row 2, column 3. Whatever position you're trying to fill, that's the row and the column you multiply. Alright, so you feel like you got matrix multiplication under control? Alright, then we're moving on. The next thing we're going to talk about is something called the determinant. And the determinant is simply a number that is associated with every square matrix. Okay, so the matrix must be square. Can't do a determinant unless the matrix is square. I'm going to show you how to get this number. So 3a. The problem looks different. What is different about the way that problem looks than the ones we have been doing so far this morning? There's no bracket. It's just straight lines, right? What do those straight lines remind you of? Absolute value. And this is just going to be a single number. It is not going to be a matrix. It's going to be a single number. How do I find that number? Well, it's very, very easy. You multiply these two together. So 1 times 4. You multiply these two together. So 3 times 2. And then you subtract them. Okay, so this is not matrix multiplication. We did that already. This is something different. So 1 times 4 minus 3 times 2. So the answer to the problem is negative 2. A single number calculated by doing this minus that. Can you do B? What would B be? Two times 7, 3 times negative 1, and subtract them. So what is that? Watch your arithmetic. Isn't it 14 plus 3? So that's going to be 17. Matrix operations are really easy, but there's a lot of arithmetic, and so you have to be careful. How about C? Can you do C? What do you think the answer to C is? Negative 11. Negative 11. Remember, we always multiply this way first. So it's going to be negative 1 times 3 and 2 times 4, and we're going to subtract them. So negative 3 minus 8, so negative 11. Determinants only apply to square matrices. So B is a square matrix, but it's bigger. How do we do this? Here we go. Step one. Take these two columns, right here, these two, the first two columns, and reproduce them out here. So 1, 0, 1, 2, -1, -2. So just the first two columns, and you tack them on in order. So first, second, tack them on in order. Now, multiply these three numbers together, right there in that diagonal. Multiply all of those numbers together. What do you get when you multiply? -1. Multiply these three numbers together. What do you get? 6. And finally, multiply these three numbers together. What do you get? 0. Now, add those up. So -1 plus 6 plus 0 is 5. We're not done. Now we gotta go the other way. Multiply these together. What do you get? 0. Multiply these together. What do you get? -6. And multiply these together. What do you get? 0. And add those up. So that's just -6. Now, remember, that's just a bigger version of this. So over here, we did this diagonal minus that diagonal. Well, here, we've got 3 of these, and we've got 3 of these, but we're still gonna subtract. So our answer is 5 minus -6, which is 11. So the downs total up to 5, the ups totaled up to -6, and then I'm gonna subtract, just like I did over here, downs minus.
What do we do for leftover numbers?
Nothing. I mean, every number is used, because like that 0 is right there, so it got used. It just didn't get used in that spot. All right, can you remember the steps? What do we do first? We're gonna evaluate this determinant. What do we do first? We rewrite the first two columns, and we're very careful, trying to keep organized. And then we always start here. Always start here. And multiply those three numbers together. So 3 times 4 times 3. 36. And then multiply these three numbers together. 0. And then these three numbers together. So total them up, 37. Then turn around and go the opposite way. So what are these? Multiply, multiply, multiply. So that is going to be -8. These three, multiply them together. Those three will make a 0. And these three will make a 6. So that gives me a total of -2. And then to get my answer, my final answer, I take 37 minus -2. So the determinant value is 39. Determinants have uses. We're gonna find out here in a couple minutes what one use is, but there's one more example problem. Can I have a volunteer to come up and do it on the board? one more determinant. Thank you, Anand.
We come this morning.
We come this morning. So all of us are working on this, because we're gonna check the guys' work. See if they are right. Tomorrow, wait, do I see you tomorrow? No. Next class, we have gotta have our calculators, because we're gonna be doing some of this matrix stuff on our calculators. So make sure you have it. They got -16. What did you get?
16.
You got +16? -16, yeah. I think they're right. I think they're working exactly right. Does anyone have a question about that? All right, we have one more thing to talk about today, and that is the inverse. The inverse. And like all these things we've been doing, it's easy, but you have to remember the steps to follow. So here's how this works. Matrix A looks like this. Our job is to find the inverse. This is called the inverse. Okay? Step 1. Find the determinant. That's what we were just doing. So to find the determinant, remember we multiply, and subtract. So we get 5 minus -2. I got 7. Did you get 7?
Yes.
Okay? Now hang on to that number. We're gonna need it here in a minute, but we're gonna do something else first. So once you find your determinant, now you're going to make a new matrix. Right? In the new matrix, this is gonna seem really, really weird, but the new matrix is found by taking these two numbers of right point and switching them, flip-flopping them. So the 5 will be here and the 1 will be here. So we take these two numbers, this is the original problem, we're making a new matrix by flipping these two, switching their positions. Then these guys, so these flip, these guys, if it's negative, you make it positive, and if it's positive, you make it negative. So these two switch places, and these two get their signs changed. So if they were both negative, they'd both become positive. Okay, now, take that new matrix that you built and divide everything by the determinant. And that is your inverse. Now, if I were you, I'd be thinking this is the weirdest thing ever. And you're right. There are mathematical reasons for all that, but we're not going into it, we're just going to find the inverse.
So we just leave it like divided by 7, don't just solve it.
We need to solve it.
Do you want us to put in divided by 7 and put like a decimal?
No, just leave it like that. Now, if the fractions reduce, you wanna reduce them, but none of those reduce, so we're good. All right, let's try the next one, see if we can remember some of these steps anyway. What's the first thing we do? First thing we do is find the determinant. All right, so what's my determinant? My determinant will be 4 minus 0. So 4. My determinant is 4. 4 multiply 4 multiply 0 and subtract. Now I'm going to make my new matrix, which has a name, by the way. It's called the adjoint, but you don't need to worry about that. We're just going to make a new matrix. And how do we do it? These two get flipped. And these two, if they're positive, they become negative and vice versa. Well, 0 is 0. And that's a positive 3. Then to get my answer, I'm going to take every one of these and divide by 4. So I have 1 3/4, 0, and 1/4. There's your inverse. Always simplify your fractions. Okay, you ready to try one on your own? All right, here we go. Go ahead and try A on, or C, I mean, matrix A. Try this and see if you can find the inverse. Did you get 10 for your determinant? So, what do you think? Does that look like yours? Remember, you gotta reduce your fractions.
So if we don't simplify, we get points off. If we don't simplify, we'll get points off.
We always reduce our fractions.
What if like one of the fractions you get to like divide out evenly and make like a whole number?
Then you make it a whole number.
Okay.
All right, one more, guys. Don't, you're not packing up yet. One more. Letter D. Now this one's a little bit special. What is the determinant of letter D? 0. Now why is that going to be problematic? Think about what you do with the determinant. Your determinant is not doing 0. What do? Oh, you have to divide by that? And you can't divide by 0, right? That's not allowed. So D has no inverse. There's no inverse because the determinant came out to be 0. And when you make your new matrix, you would have to divide by 0, and that can't be. You can't do that. So D is called non-invertible. It does not have an inverse. You can just say no inverse. Okay? All right. 7-2 homework due on Monday. And on Monday, when we have class again, make sure that you have your calculator ready to go because we're going to be doing a bunch of
calculate.